acid, we will be discussing about the chemical properties of the carboxylic acid. In earlier sessions, we have discussed the preparations, physical and chemical properties, nomenclature of aldehyde ketones, as well as the preparations and nomenclature of aldehyde ketones and carboxylic acid. So let us start the today's session. You must take your pen and paper before attending this session. Let us talk about the properties of carboxylic acid. Basically, the chemical properties of the carboxylic acids. As we know the structures of carboxylic acids as they are COOH. If we draw the general structures of all carboxylic acid, it should be look like this: RCOOH. So if we look in at the we can see over here that the alkyl group or alkyl chain is here. In only in formic acid we have the hydrogen atom. Otherwise, the alkyl chains are attached with the carbon. The functional group of the carbon the carbon of the functional group is counted, while the nomenclature, as we know that here if we look at the structure, we have the carbonyl bond, that is C double bond O, and we have the COH. We have some properties which shows the acidic nature of the carboxylic acid as the removal of H plus. Some properties may be there as the removal of this COH, removal of this OH, and other properties may be deal with the properties of this whole functional group, that is COOH. So let us move further. Reactions involving the cleavage of OH bond, that is acidity, reaction with metals and alkalis, and effect of the substituents on the acidity of the carboxylic acid. Very important topic. Reactions involving the cleavage of COH bond, as I told you, formation of anhydride, esterification, and the reactions with PCl3, PCl5, SOCl2, etc. And one more reaction, very important, and the whole syllabus of the 12th is important, as I always say that, but some reactions which are of more important, that is the reaction with the ammonia derivative. The reaction with the PCl3, PCl5, SOCl2 wholes, that is removal of OH from here. Similarly, with ammonia, when they react with ammonia, the OH is substituted with NH2 group or NH4 plus group. In reactions involving the COH group, that is the reduction and the formation of anhydride. And those two types of reactions we will study over here. That is the reduction and decarboxylation. Substitution reaction in the hydrocarbon part, that is halogenation, ring substitution. Both type of reactions we will go through. Let us start with the first type of the reactions. Those are the reactions involving the cleavage of OH bond. That is, OH bond means the removal of H plus from here. Okay, that is the acidity, the reaction which shows the acidic nature of carboxylic acid. As we know that the acid gives hydrogen when they react with metals and alkalis. So when they react with carboxylic acid, organic acid reacts with sodium metal to give hydrogen. Similarly, they react with the NaOH and sodium carbonate to give water and CO2 respectively. When they react with sodium metal, they give hydrogen. they react with any OH to give the as sodium acetate of the similar is the similar reactant. We can say that if we take as the ethanoic acid over here, they react with ethanoic acid reacts with sodium hydroxide. It forms the sodium ethanoate, and propanoic acid reacts. It forms the sodium propionate. Similar. I mean to say the reactant which we use it give its corresponding sodium salt. So there are some factors which affect the acidity of the carboxylic acid, and why the carboxylic acid are more acidic than the alcohols and phenols. It is very important question that carboxylic acid are more acidic than the alcohols and phenols. In the alcohols, we know that the OH bond is also there, but the carboxylic acids are more acidic. These are more acidic because the resonance stabilization of the functional group. If we look at the carboxylate ion, or let me clean this carboxylate ion, that the carboxylic acid group, this is the carboxylic acid group. When in presence of the water, it gives the hydronium ion. Let me draw it some more border. The broader, that is the carbonium ion, and the oxalate ion is here, and carboxylate ion is here. Carboxylate ion is the resonance stabilized. Then, due to its resonance stabilization, the removal of H plus is easy. H plus can be easily removed. No. If we have the smaller negative on the corresponding atom or ion from where H plus is to be removed, the smaller H plus, smaller negative charge or resonance stabilization facilitates the removal of H plus ion. So that's why carboxylic acids are more acidic than the alcohols and phenols. The presence of electron withdrawing group facilitates the removal. That is, the removal becomes easier due to the stabilization of carboxylate anion. An electron donating group destabilizes the carboxylate ion and weakens the acid. That is, the removal of H plus becomes difficult. That's why the different groups which are attached to the carbon chain affects the acidity of carboxylic acids. We must aware of the Ka values and pKa values. Ka value means the dissociation constant, which is represented by the Ka in case of the acids. General representation of the equilibrium constant is Kc. As we know that carboxylic acids are the weaker acids, that's why an equilibrium is established between the H plus ion and the corresponding acid. So there we can write the value of Kc for these. That is dissociation constant. Since it is an acid, so Kc is represented as the Ka in case of the acids. So when a substituent is, and pKa is what? pKa is power of, we know that as the pH is there, the pKa is there. pKa values are given in the NCERT for different acids. It is the minus log of log to the base of 10 of Ka values. Ka values. So when substituent is present like chlorine, chlorine, and NO2 electron withdrawing groups are there, what will they do? They increases the acidic nature, facilitating the removal of H plus ion. When three fluorine atoms are present, acid is most acidic. Stronger acid it is, we can say that. We can look at the series, we can look at the different substituents which affects the increasing acidic character. Increase in acidic character, I mean to say that. Fluorine, nitro group, cyanide group, they have three fluorine atoms are present here, single fluorine atom is present. So, in this way, the acidic nature can be compared. So, there might be a question in your question paper relating to the acidic nature of the carboxylic acids. In the NCERT, in text questions also deal with this. We'll discuss the questions in the question answer sessions. Reaction, effect of substituent on the carboxylic acid, and sp2 hybridized carbon is there. That is the vinylic carbon or phenylic carbon. The direct attachment of phenyl or vinyl group increases the acidic nature to the decrease expected due to resonance. And the resonance, that's why the sp2 hybridized carbon, in case of it is connected directly to the functional group carbon, it increases the acidic due to resonance. Let us talk about the more, that is the EWG, that is the electron withdrawing group attached to the uh, aromatic ring, increases the acidic nature. If we look at the pK values, for nitrobenzene, the pK value is 3.1. Benzoic acid, it is 4.19. And in case of the methoxybenzoic acid, it is 4.46. So it is the electron donating group. EDG is there. EDG is there. That's why the acidic nature decreases. Okay. So pKa, greater the pKa value, weaker is the acid. Nitrobenzoic acid is most acidic over there. Let us see some more things. Reactions involving the OH group, cleavage of OH group, formation of anhydride. It's a very, very studied reaction. Many times we use this reaction when ethanoic acid is heated in the presence of a anhydrating agent, that is like the water removing agent, I can say there, like it is heated with P2O5, phosphorus pentoxide. It forms the anhydride, removing the water molecule from here. We can see that OH from this and H from this, one water molecule is removed and we got the anhydride. This is the anhydride of acetic acid, ethanoic anhydride. Its name is derived from here. Very, very important mechanism is also coming here with the name esterification. Carboxylic acid reacts with alcohols in the presence of mineral acid to form a new functional group, that is esters. Mechanism of the esterification is also in our syllabus. Let us during the esterification, it may be expected that the acidic, like carboxylic acids are acidic in nature, they must give H plus and alcohol should give OH. But if we look at the mechanism, at the end of the mechanism, we must be able to understand that during the formation of ester, OH group is given by the carboxylic acid and H plus are given by the alcohols. If we look at the first step over here, the H plus from the mineral got attached to the, we can say that it protonates the carboxylic acid. It protonates the carboxylic acid. COH is here. We can see over here the negative charge dispersal on this oxygen, and H plus may be connected to this. In this way, OH is formed over here, giving the positive charge to the oxygen, which is not favorable for the oxygen. So what will happen? The oxygen will try to remove this negative, this positive charge from here. What will happen? A new molecule, if a new molecule of alcohol will attack on this positively charged carbon, forming a tetrahedral intermediate. And during the intermediate, when intermediate is formed, again we have the positive charge on the oxygen over here. So proton will get transferred from here, and we got the ester at the end of this process by removing the H2O from here. You can see there. Here the H2O is formed. You can understand here the H is removed and EH got attached to this. Any of the oxygen can be used by whether this or this, but this is not used because we have the positive charge on it. So what will happen? This will attract this hydrogen over here. So it, and one water molecule is removed from here. We got the protonated ester. By removing the proton from it, it will give the ester. So with this mechanism, we are able to understand that OH group is given by the carboxyl and H plus is given the alcohol. In this way, we have completed the process of esterification. Thank you, everyone. Thank you. We will study more properties in the next session.